stratified random sampling. Stratified, what that mean? Cut it into chunks, right? There's a lot of research for stock market or for the weather, global warming. And there's one research is all about what window size you are going to make a good sampling. The window size, I found study, I know in the physical science, they use the fraction Brown motion to make this different window size of the weather. You know, long time weather, upper atmosphere weather. James Warners used to get the Korea award. He did a very good job on that. Used the fraction Brown motion. Basically, the phenomena in the nature have big cycles, small cycles. You don't know, but you can visually kind of see one time has a little jump, and then come back and repeat the pattern again, like periodical in every 300 years. Who knows? For the stock market, we know 9 years usually have a cycle of up and down for economics. I don't know if it's psychological or because of the generation mentality. We don't know. But we do know 9 years is a good window to look at the long-term trend. We cut in those windows, and that's called a stripe. And then we're going to sample it along this stripe randomly, and be the representative of this window, time window. Or if you look at the polling, the population, or the income, you might divide this stripe, this group into ethnic group or location group, big city resident or inland, you know, interlocked land or city, big city, or you know, they usually have a multiple way to separate the group, and you need to sample in each group depends on the base proportionally. Need proportionally. Like okay, a few is called Southerner Caucasians, another maybe a Northerner Caucasians, location and race, and then you say oh conservative blacks, up-level blacks, low-level blacks, intercity blacks, and those things you can put it a different category. Or Asians, you can think about the Asian have this professional Asians come here as the high tier of labor like myself, or those come here for the restaurant, you know, run the restaurant, or illegal. Those things you need a little representative in every every group, but little proportional. Because if you make one group 280, you're going to tilt the data, not telling biased. So not biased in the proportion to the size of the population, subpopulation. Cluster sampling we talked a little bit before. Like actually this itself is a little bit cluster. When you do this, you are talking about an attribute distance. The attribute distance based on social, economic, and the ethnic group and the religion, all those things. The politicians know how to do that very well. And whenever they talk to a group of people, they know how to dress and the talk. So that's a cluster. The cluster can measure the distance about the income, religious believer, and the ethnic background, which region you are, and all those distance, they can be a representative group. It itself is a cluster. And then the cluster sampling, you can use this mean, that means the centroid, like a physical science concept, and then what distance around this centroid is one cluster. And when we talk about K-mean, nearest neighborhood algorithm, we're going to know this. Just a vote. For example, if you can find 5 representative group, you will have the short distance to this 5 votes that are similar, you belong to that group. So like this. There's a lot of good algorithms. Also, clusterization is called the unsupervised learning. You don't need to supervise, you don't need the training data. All you measure is the distance and the similarity you're going to measure. So that's easy. And another good feature of this way is you don't need to worry about storage because that's case-based. One scan out. You don't need to look at the global thing and look at the things. You just based on case-to-case measure the distance you've done. That is very nice for huge data. To like natural language processing. You can use that there. And the systematic sampling, what I'm talking a little bit of systematic sampling. When the Gallup people do the polling in the American population, you know what they did? They did about 200 years now. They're the #1 company in Nebraska. I've been there, Omaha. Beautiful company, you know, the dream company you would like to work for. They had a lot of money. You know, a woman work there, you have babysitter and everything. The CEO is at the corner of the entrance. Every time you come in, they really did a good job. It's just that data is money. Nowadays, those data are huge money. And their computer is layer by layers protected. They predicted the summer revolution in a country 10 years earlier. See who is going to run the rebellion, a coup, or those things. They predict very accurately. They have a lot of things they can brag. And of course, they know where is the next Chinese president from which people. And their kids maybe will have a chance to go to Harvard. You know, before they ever got this two candidates to be the president, the two of their children are both in Harvard. That's a good job. I mean, not just the Gallup, maybe CIA, and they know. Of course, data is always related with those jobs, FBI. I don't know what convenience sampling. I just got it from judgmental sampling. I don't think it sounds like a common sense sampling. Not a common sense. It's your understanding of your data. That makes a whole difference. If you work in medical data in your team, you must have a doctor. Without that, you have a lot of blind angle. The statistic won't tell. But next time I can show you some statistics. You can have exact the same regression, deviation, but they're not the same thing.